Hi everybody, welcome to my channel again. This is Oliver. We are learning algebra by working through problems from the Larson textbook. This is section 1.5 that we're doing, use a problem solving plan. And today we're doing a review for mastery and challenge practice problems. All in all, about 12 problems. So let's start. The first problem, a salesman is reimbursed $50 a day for food and lodging. He also receives 35 cents for each mile driven. He drives 124 miles and is reimbursed $193.40. How many days was the trip? Okay, so we don't have to solve the problem. We just have to state what we know and what we need to find out. So what we know is the reimbursement of the salesman per day, which is $50. We know that for each mile he drives, he receives 35 cents. We know that he drives 124 miles, and the total reimbursement amount that he gets is $193.40. What we need to find is the number of days the trip was. Okay, so that was an easy one. Number two, use a problem-solving plan to solve the problem. You have saved $165 to buy a video camera that costs $300. You plan to save $15 each week. How many weeks will it take you to save for the video camera? Okay, so we have saved $165 plus we're saving $15 per week, but we don't know how many weeks and we're gonna earn $300 so that we can buy the video camera. So this is the equation, and we have to solve for x. So 15x is 300 and minus 165, because 165 has a plus sign. When it goes to the other side, it will become minus 165. So this becomes 300 minus 165, or it's 135, right? And then x equals 135 over 15, or that is 9. So 9 weeks. Okay. So you're gonna need 9 weeks to buy that video camera. Okay, so next, that was number 2. Number 3, actually 1 through 4 here. So N television, N is saving money for a television that costs $180. She makes $8 an hour babysitting, and her parents will give her or contribute $60. How many hours does she need to babysit? So she has $60 plus $8 times how many hours to get 180, right? So we have to see how many hours she needs to babysit. So 8x equals 180 minus 60, because plus 60 on the other side will be minus 60. 180 minus 60 is 120, and then x is 120 over 8, or that is 15. So she needs to babysit 15 hours to buy the television. Number 2, aquarium. It takes 28 trips to fill a 14-gallon aquarium with a pitcher. How many trips with the same pitcher will you need to fill a 32-gallon aquarium? So 28 trips, it fills 14-gallon aquarium. And then how many trips, x trips, to fill a 32-gallon aquarium? So when you have something like that, x is you cross multiply and you divide by the opposite one. So x is 28 times 32 divided by 14. So let's see. I'm gonna plug that in the calculator, and we're gonna get 28 times 32 divided by 14. We get 64. So you need 64 trips. Number 3, piano. You practice piano for 1.5 hours each weekday, and then 2.5 hours each weekend day, Saturday, Sunday. How many hours per week do you practice? So we have 5 weekdays, Monday, Tuesday, Wednesday, Thursday, Friday. So that's 5 days. You practice 1.5 hours. So 5 times 1.5. Plus you practice 2.5 hours times 2 days, 2 weekend days, Saturday and Sunday. Okay. So 5 times 1.5 is 7.5. That's how many hours you practice during the weekdays, and then plus 2.5 times 2 is 5 hours. That's what you practice on weekends. So this is 12.5 hours. Okay, that's 3. 4, you're making lasagna for 25 people. It takes 8 ounces of mozzarella cheese to make enough to serve 10 people. You have 12 ounces of mozzarella cheese. How many more ounces do you need? Okay, so we know that 8 ounces serves 10 people, 25 people, how many ounces? So 25 divided by 10 times 8 is the ounces you're gonna need. And then you have 12 already, so minus 12, whatever that amount is, that's the number, that's how many ounces you're gonna need. So 25 times 8 is 200 over 10 is 20 minus 12 is 8. So 8 ounces is the answer, is what you need. Okay. Next is the challenge practice problems. Number 1, you and your friend leave school to go to the city library. So let's say this is the school right here. So let's just say school. And then library, let's say it's here. Just 5 miles away, so we know it's the distance 5 miles away. Your friend leaves when school lets out at 3 p.m. So this is your friend at 3 p.m. and walks to the library. So he walks. You have to stay behind for a club meeting and leave 1 hour later. So this is you here. You are leaving at 4 p.m. You both arrive at the library at the same time. So right here, T is the same, so you arrive at the same time. After studying for 2 hours, so you study for 2 hours. Your friend does an errand. Your friend does an errand, walking to a shop 1 mile away. So this is 1 mile away to a shop. Your friend walks at the same rate as before and takes 20 minutes. 20 minutes to make the walk to the shop. So if you take a look at this one right here, and we know the formula, right? It's D equals RT. D is the distance, R is the rate, T is the time. Here we have the distance 1 mile, we have the time 20 minutes, we can find the rate of the friend walking. So it would be D is 1 mile, so 1 equals R is the unknown times T is 20 minutes, or that's 1 over 3 hours, right? Because there are 3 20-minute chunks in an hour, so that's 1 over 3 hours. Or only R for the friend, the rate of walking of the friend would be 1 over 1 over 3, or that's 1 can be represented 1 over 1 over 1 over 3, and then we multiply outside terms and inside terms. So 1 outside, 1 times 3 is 3, 1 times 1 is 1, 3 over 1, or that's just 3. So your friend is walking at 3 miles per hour. Okay. What time is it when your friend arrives at the shop? Right here. Okay. So he leaves at 3 p.m. We know the distance 5 miles to the library. So we have to find out the time he arrives at the library. So we know the rate now. The rate is 3 miles per hour and the distance is 5. So we plug in the numbers in this formula here. So we get the distance is 5 miles, right, from the school to the library. The rate of walking of the friend is 3 miles per hour. We know that, times t. So t would be 5 over 3. 5 over 3, or that's 1 hour and 2/3, or that's 40 minutes. 1 hour and 40 minutes. So if he leaves school at 3 p.m., 1 hour and 40 minutes, when you add to 3 p.m., it's 4 p.m. and 40 minutes. So 4 p.m. and 40 minutes, 4 and 40 p.m., I should say, but 4 p.m., 4 o'clock and 40 minutes, he arrives at the library. Now they spend 2 hours studying, right? So that's 6:40. And then 20 minutes he walks from the library to the shop from 6:40 from right 4 o'clock and 40 minutes plus 2 hours is 6 o'clock and 40 minutes, and then 20 minutes walking, that's 7 p.m. That's the answer for 1. Okay. Number 2, in exercise 1, how long did it take you to bicycle? So this is for you. You're bicycling, right? Bicycle. How long did it take you to bicycle from school to the library? How long? Okay, so you need the time to find the time, and d equals r times t. It took you 40 minutes, right? Because you arrived at the same time. We found the time when your friend arrived at the library, which was 4 p.m., 4 o'clock and 40 minutes. You started at 4 p.m., so it took you just 40 minutes to arrive there at 4 o'clock and 40 minutes, right? This is 4 o'clock and 40 minutes. You started at 4, so how long did it take you? 40 minutes. You don't even have to calculate. Just subtract 4 o'clock and 40 minutes from minus 4 o'clock, that's 40 minutes. Number 3, in exercise 1, if you offered to do the errand for your friend on your bicycle, how long would it take you to travel from the library to the shop? Okay, so from here to here, what if you bicycled for your friend instead of walking? We know that bicycling is faster than walking, so should be less than 20 minutes. Okay, so now the formula again is d equals r times t. We have to find t. The distance is 1 mile from the library to the shop. How about the rate? Well, the rate we have to find out from here. So let's find out the rate of the bicycling, right? So the rate is d equals r times t, the formula, and the distance here is 5 miles, and the rate we don't know, times tt. As we said, it takes 40 minutes to cover that 5-mile path. 40 minutes is 2/3, right? 2/3 of an hour. And r would be 5, or 5 over 1 over 2/3, because 2/3 multiply here, on the other side will divide. And 5 can be represented as 5 over 1. It's the same thing. And then now we multiply 5 times 3 is 15. 15 over 2 times 1 is 2. 15 over 2, or that is 7.5 miles per hour. Miles per hour is your rate. Now we know the rate of the bicycling. We can get the time it takes from the library to the shop. We use the same formula again, d equals r times t. D is 1 mile, so 1 mile equals, now the rate we know, it's 7.5 miles per hour times t, and then t would be 1 over 7.5, and then let's see, 1 divided by 7.5, or that's 0.13 or 8 minutes. So is going to be 8 minutes. This is the answer for number 3. Number 4, you and your friend decide to meet at the city pool to swim. You both leave your houses at 8 a.m. and bicycle to the pool. Okay, so this is you and this is your friend. Decide to meet at the city pool. So this is the city pool here. You both leave your houses at 8 a.m. So 8 a.m. you leave your houses and bicycle to the pool. So you bicycle, and then your friend also bicycles. Pedaling at a rate 5 miles per hour faster than your friend, you arrive at the pool and have to wait 12 minutes. Okay. For your friend who is pedaling at a rate of 10 miles per hour, okay, so your friend, the rate is 10 miles per hour, and we know that you're pedaling at a 5 miles per hour faster than your friend, so your rate is 15, 10 plus 5, or 15 miles per hour. Okay, so we know the rates, right? Okay. Once your friend arrives, you both swim for 2 hours. Okay, so you swim for 2 hours. You swim for 2 hours. And then return home. And then you go home. Okay. Once your friend arrives, then returns home, pedaling at the same rates as you did in the morning. You arrive home at 11:48. So here, 11:48 a.m. you arrive home. What is the distance between your house and the pool? So your house and the pool, this distance x equals question mark. That's what we have to find. We know the formula is d equals r times t. D is the distance, that's what we have to find, or x actually, let's just say d. D equals question mark, so that's what we have to find. The distance equals r times t. R is 15 miles per hour, so that's we know the rate, so that's good, 15 miles per hour. The time we can figure out. How? Because the start time and the end time is given, and so we have to subtract 11 o'clock and 48 minus 8 o'clock, the start time. So that's 3 hours and 48 minutes that we were out of the house. So it took us to go to the city pool and come back, but within that time we have the 2 hours that we were swimming, we weren't bicycling, right? So the formula is we have to be bicycling, right? We have to subtract the swimming time, so that's 2 hours minus 2 hours swimming, so that's 1 hour and 48 minutes. But then also you had to wait 12 minutes for your friend to arrive, so minus the 12 minutes that you were waiting, you weren't bicycling, you just waited there, so that's 1 hour and 36 minutes. So that's the actual time of you bicycling to the city pool and back, right? So you covered 2 trips. We just need to find the distance from you to the city pool, not to the city pool and back. So okay, so the distance here in the formula is actually 2x because it goes to the city pool and comes back, and then the rate is 15, and then times t, the time is 1 hour and 36 minutes. So that can be represented as 1 hour and 36 minutes, 36 over 60, or 2x equals, so let's plug that in the calculator. 36 divided by 60 is 0.6, and 1.6. So 1.6 times 15, you get 24, and then x is 24 over 2, or just 12. and that's miles, 12 miles, right? So that's for number 4. So number 4 is 12 miles. That's the answer for number 4. Number 5, in exercise 4, what is the distance between your friend's house and the pole? Okay, so we have to find this distance right here. So let's say that's D2. That distance is different than the distance between you, your house, and the city pool, because obviously your rate of bicycling is faster and you have to wait there 12 minutes. So let's see. So D2 equals the rate, which is 10 times the t, times t, right? We have to find D. The rate is 10 times the time. So we know now the distance, x, right? X is 12 miles. So let's do this. D equals R times T. The distance between you and the city pool is 12 miles. The rate is 15 times T, or T is 12 over 15. You divide by 3. It's what? 4 over 5? 4/5. And that's what? 4 divided by 5. That's 0.8. Or that's 48 minutes. Right? That's 48 minutes. Or you can say 4 over 5 hours. 48 minutes. And then you had to wait for 12 minutes, right, for your friend to arrive. You started at the same time, 8 a.m. So you arrived there for 48 minutes. But then, so it was 8:48 when you arrived there. But then you waited 12 minutes for your friend to arrive. So your friend arrived here at 9, right? 8:48, and you add 12 minutes, that's 9 a.m. So your friend arrived at the city pool at 9 a.m. From 8 a.m. to 9 a.m., that's 1 hour. So that's 1 hour here. So 10 times 1 is 10. So the distance is 10 miles between your friend's house and the city pool. That's the answer for 5. Number 6. Again, these are high-level problems. If you know how to solve these, you should be in good shape for quizzes, tests, college entrance exams, everything. Number 6. In exercise 4, suppose that after swimming, you both decide to ride your bicycles to your friend's house. Okay, so right here, after you're done swimming, you both decide to ride your bicycles to your friend's house. If you both were to ride at the same rates as you did in the morning, how long would you have to wait at your friend's house before your friend would arrive? Okay. So again, same formula, D equals, so let's, this is the city pool right here. And this is your friend's house. Your friend's house. Now the distance we know is right here, D2, 10 miles. So we know the distance is 10 miles. The formula is D equals R times T. The U, so let's do first U, and then your friend. So U, the distance is 10 miles, so 10 equals R is 15 miles per hour, so 15 times T, or T is 10 over 15, or that's 2/3 of an hour, or that's what, 40 minutes. Right, there are 3 20-minute chunks in the hours, that's 40 minutes. So you arrive there in 40 minutes. And then your friend, using the same formula, the distance is 10 miles. So the distance is 10 miles. So 10 equals R is 10 miles per hour, right here, times T. So T, 10 over 10, or 1 hour. So your friend, it's going to take your friend 1 hour to get from the city pool to his house, and it's going to take you 40 minutes to get from the city pool to your friend's house. So the question is, how long would you have to wait at your friend's house before your friend would arrive? 20 minutes, right? Because it's going to take you 40 minutes, and then your friend is going to take him 1 hour. So you're going to have to wait 20 minutes. So 20 minutes is the answer. 20 minutes. So with that, that's all for today. Please, if you like this video, please like and subscribe to the channel so you see more videos of this type. Thank you so much, and see you next time, guys. Bye bye.